Welcome to the deep dive. So today is April 15, 2026, and Meta just dropped a massive tectonic shift right on the AI landscape.
Yeah, they really did. I mean, giving away a multi-million-dollar asset for free is just wild.
Right. And to be clear, for you listening, this isn't charity. It's a strategic earthquake. It fundamentally threatens the whole business model of proprietary giants like, OpenAI and Google.
Oh, absolutely. It shifts the entire gravitational center of the tech industry.
Yeah.
We are looking at a completely different map today than we were yesterday.
Yeah, the concept of who controls foundational intelligence is just completely inverted now.
It really is.
So our mission today is to unpack a fresh analysis from Gate of AI. They've been tracking this release, the Meta Llama 3 models.
Specifically the 8 billion and 70 billion parameter versions, right?
Exactly. And these models, I mean, they're engineered to handle everything from standard natural language to really complex step-by-step reasoning.
Which is huge.
Right. But the real kicker here is that they are globally accessible. Anyone can get them.
And that global accessibility completely changes the context, like how frontier models are deployed across the whole industry.
Yeah, we're basically witnessing a shift from renting intelligence to, well, actually owning the infrastructure.
Exactly.
Before we get into the tech, I want to look at the business side. Think of the dominant AI business model like an ultra-exclusive country club.
Okay, I like that analogy.
Right. So developers and enterprise startups, they're paying these hefty monthly API dues.
Huge fees.
Right. And they have to operate entirely within the club's closed ecosystem.
Mm.
And crucially, they don't own the golf course.
Right. They're just renting access.
Exactly. The beautiful course, but your access is subject to arbitrary pricing changes. And that what Meta essentially did overnight was like buy the massive plot of land right next door.
And they built a state-of-the-art public park.
Exactly. A public park with an objectively comparable golf course. And they just unlocked the gates for everyone to use, no subscription needed.
And the Gate of AI report really highlights this as an existential threat to those closed-source competitors.
I mean, how could it not be?
Right. For the last few years, the true cutting edge was locked behind those country club doors. But now you have models matching that proprietary performance without the licensing fees.
Or the restrictive vendor lock-in.
Exactly.
Okay, let's unpack this, though, with a little skepticism.
Yeah.
Because Meta isn't a nonprofit.
Obviously not.
Right. They spent tens of millions of dollars in sheer compute power and engineering talent to train these models.
A massive upfront cost.
Yeah. So if they aren't charging API fees to recoup that cash, is this just Meta being generous to the community? Or is this a calculated strategic play to completely erode the business models of their competitors?
Oh, it is highly calculated. It looks like a massive loss leader until you understand the economic strategy of commoditizing your complement.
Okay, break that down for me.
Sure. So Meta's core business relies on maximizing global user engagement, right? Hardware ecosystems, digital connectivity.
Right. Ads, social networks, VR headsets.
Exactly. They don't actually need to sell cloud compute or API access to survive. So by open sourcing a frontier model, they effectively drive the price of foundational AI logic down to zero.
Wow. Which severely erodes the primary product of their proprietary competitors.
Exactly. While simultaneously ensuring that the next generation of enterprise tools, apps, and academic research happens entirely on their architecture, the Llama architecture.
Oh, I see. So they want to become the default operating system for the entire AI industry.
Yes. Because if every developer builds familiarity with the Llama ecosystem and hardware manufacturers optimize their silicon for it,
then Meta basically dictates the universal standard.
exactly, they become the inescapable infrastructure.
That is brilliant, but also brutal.
It is. If the open source alternative is highly capable, heavily supported, and completely free, companies selling access to proprietary models are forced into a brutal corner.
Right, they either have to drastically cut their API prices or open up their own closely guarded tech.
Yeah, just to compete for developer mindshare. Or they have to invent capabilities so profoundly beyond Llama 3 that developers are willing to pay a massive premium.
So it democratizes access for you and me, but it's basically a predatory pricing strategy against closed ecosystems.
That is the perfect way to summarize it, yeah.
But, a public park only draws members away from the country club if the facilities actually hold up.
Right, it has to be genuinely good.
Exactly. The open source label doesn't give a model a free pass on performance metrics, especially in enterprise environments.
Not at all.
So let's look at how Meta squeezed this level of high-end performance into these models without requiring end users to own, like, a specialized server farm.
Yeah, the gate of AI analysis really zeroes in on efficiency as the new definition of power.
Which makes sense. Raw computational power is a brute force approach, right? It limits accessibility.
Exactly. The real engineering marvel of Llama 3 is how much reasoning capability they packed into a highly efficient computational footprint.
So what are the specific leaps here?
The report highlights three massive technical leaps. First, a refined tokenizer yielding up to a 15% efficiency gain.
Okay, 15%.
Second, the integration of group query attention, or GQA. And third, the use of highly detailed predictive scaling laws during development.
Let's start with that 15% tokenizer efficiency.
Sure.
I mean, for you listening, if you know the basics, you know tokens are just the fundamental units of model processes.
Right, like words or parts of words.
Yeah. So if tokens are the gas an AI uses to travel through a prompt, this new tokenizer is like a hybrid engine that gets you 15% more miles to the gallon.
That is a great way to put it.
But wait, a 15% improvement seems like a minor optimization, right? Not a revolution.
Yeah.
Why is the report treating this specific metric as a fundamental game changer?
Because at the scale of global enterprise deployment, a 15% gain in token efficiency compounds exponentially.
How so?
Well, consider the massive context windows developers rely on today. They're feeding entire software code bases or dense legal contracts into a single prompt.
Right. Huge amounts of data.
Yeah. So if the new tokenizer's architecture packs more semantic meaning into 15% fewer tokens, the model doesn't just read the prompt faster.
It requires less memory.
Exactly. It requires 15% less active memory allocation to hold that specific context in its working memory.
Oh, wow. So you can execute the exact same complex tasks, but it costs less compute.
Precisely.
It's not just saving compute on the input processing. It's actually physically expanding the functional capacity of the model's context window.
Yes, you can fit vastly more complex instructions into the exact same memory constraint. And furthermore, output generation speeds up proportionally.
Because it's generating fewer total tokens to express the same thought.
Exactly. So the computational cost per response drops, latency decreases significantly, and the end user experience is just much more fluid.
And when you multiply that across millions of automated API calls in an enterprise app,
the reduction in server costs is just staggering.
that makes total sense. Okay, let's move to group query attention, because this is where the mechanics get incredibly dense.
Yeah, GQA is fascinating.
The report notes GQA drastically reduces computational load during inference. But does reducing computational load with things like GQA actually make the AI smarter? Or does it just make it cheaper to run?
That's a great question. To understand GQA, you have to look at the physical limitations of modern AI hardware.
Okay.
The actual speed limit for generating a response isn't the raw math. It's not the calculating power of the compute cores. It is the memory bandwidth.
Because moving data around takes time.
Exactly.
Yeah.
Moving massive amounts of data from the GPU's memory to its compute cores takes time and energy. In standard attention mechanisms, the model calculates and stores a unique memory key and value for every single token it pays attention to.
Right, the KV cache.
Yes. And as a conversation gets longer, that cache grows until it creates a massive traffic jam on the hardware.
So the compute cores are essentially just sitting there idle. They're twiddling their thumbs while they wait for the necessary data to travel from the memory chips.
Precisely. The system is memory bound, not compute bound.
Okay, so what does group query attention actually do to fix that?
It shares a single set of keys and values across multiple different attention heads.
Oh, so instead of writing unique data into the cache for every single query,
It groups them mathematically. This significantly reduces the size of that KV cache. You are essentially shrinking the volume of traffic on the data highway.
which allows the compute cores to stay constantly fed and active. It solves the memory read and write bottleneck.
Exactly.
But wait, my skepticism here is about logic degradation.
Sure.
Because if you are sharing memory keys across multiple queries, instead of giving each its own hyper-specific calculation, aren't you inherently losing nuance? Does this architecture make the model cheaper to run at the expense of making its reasoning slightly less sharp?
Well, that was the historical trade-off with older techniques, like multi-query attention. That pushed this concept to the extreme by using just one key value head for everything.
And did that degrade performance?
Yeah, it resulted in noticeable performance degradation on complex tasks, but GQA is the optimal middle ground.
Oh.
By grouping queries into smaller, specific clusters rather than one massive pool, empirical testing shows it maintains the high-fidelity reasoning quality of standard multi-head attention.
While still delivering the speed and memory efficiency.
Right, nearly the efficiency of the extreme single-head approach. Which brings us to a critical realization about the modern AI landscape.
Which is?
Efficiency is indistinguishable from capability.
Right, because if it uses live compute, you can put it anywhere.
Exactly. Because it requires vastly less memory bandwidth, developers can deploy a highly capable 8 billion parameter model directly onto an edge device.
A laptop.
Yeah, you can run it locally on a laptop without an internet connection. You bring high-end reasoning to secure, isolated environments where the latency and privacy risks of a cloud API would be absolute deal breakers.
Ubiquity is the ultimate goal.
Absolutely.
But to ensure these models were actually capable before spending the immense capital to train them, Meta relied heavily on detailed scaling laws, right?
They had to. Training a 70 billion parameter model from scratch costs tens of millions of dollars in electricity and compute alone.
Right. You don't just compile the architecture, press run on the cluster, and cross your fingers that it becomes intelligent.
No, definitely not.
The report mentions they optimized the data usage and predicted performance before full-scale training began. How do you optimize the intelligence of a model you haven't actually built yet?
By training thousands of much smaller, vastly cheaper models first.
Oh, yeah.
Yeah. Researchers plot the performance of these smaller models against the amount of compute used and the specific mix of training data, like the ratio of code, math, and natural language.
And because neural networks scale in predictable ways.
Exactly. They scale in highly mathematical ways. So researchers can extrapolate a curve from those small runs. They can mathematically project exactly how a 70 billion parameter model will behave.
And they can identify the exact data recipe required to hit a specific benchmark.
Right, before deploying the heavy compute.
They are essentially running rigorous simulations to perfect the recipe before they spend the money baking the actual cake.
That is a perfect analogy. That ensures the final product isn't over-indexed on one type of data or wasting compute cycles.
So Meta utilizes scaling laws to predict a high-yield outcome, implements GQA to clear the memory bottleneck, and optimizes the tokenizer for maximum semantic density.
And the result of those three pillars is a highly efficient, incredibly dense reasoning engine.
But theory is one thing. The real test happens when the model actually leaves the lab and gets integrated into developer workflows.
Definitely.
Which brings us to the practical applications. The Gate of AI report highlights the human evil benchmarks.
Yes. Human evil is widely considered the crucible for modern large language models.
It's a coding test, right?
Right. It's a rigorous, standardized test of a model's ability to synthesize highly functional, executable code based on a complex natural language prompt.
And Llama 3 demonstrated state-of-the-art results there, which isn't just a victory for software developers.
No, it serves as the ultimate proxy for automated logical reasoning.
Because human language is messy. It's filled with nuance, contradiction, ambiguity.
Yeah, exactly.
But code is pure, unforgiving logic. It either compiles and runs correctly, or it crashes.
Right? Navigating rigid syntax, maintaining variable states, and executing a multi-step logical sequence. It requires the model to understand cause and effect in a concrete way.
Generating a creative essay just doesn't demand that.
No, it doesn't. So when an open source model excels at human evil, it signals a deep, fundamental grasp of step-by-step logic.
Which is the critical threshold for serious enterprise applications.
Exactly. You can finally build reliable agentic workflows. AI systems that can independently plan a task, write the scripts, execute them, analyze the output for errors, and self-correct.
And all built on an architecture you inherently control.
Yes.
Here's where it gets really interesting, though. Let me throw a wrench into that enterprise adoption theory.
Okay, throw it.
We always hear about complex reasoning, but we are talking about utilizing this infrastructure for mission-critical tasks within massive corporations.
Right.
If this model is fully open source and a solo developer in their garage can download the weights, tweak them, and release a customized version, how does an enterprise CTO look at that ecosystem and see reliability?
That is a very common anxiety among enterprise leaders.
We tend to view closed proprietary systems as secure foundations. Open source can feel chaotic. If the foundational logic is constantly being modified by the public, doesn't it lose its structural integrity?
It's a fair question, but it represents a fundamental misunderstanding of how open source fine-tuning actually functions in practice.
Okay, educate me.
A developer tweaking the model for a specific use case isn't rewriting Meta's core neural weights. They aren't breaking the foundational logic that the CTO relies on.
They aren't. No.
In the modern AI ecosystem, fine-tuning relies heavily on techniques like low-rank adaptation, commonly referred to as LoRA.
LoRa. Okay, so they aren't melting down the original engine to build a new one. Explain how LoRa preserves that core reasoning capability while allowing customization.
Well, instead of updating all 70 billion parameters during fine-tuning, which would require a massive supercomputer.
And risk catastrophic forgetting, right, where the model loses its baseline intelligence.
Exactly. So instead of that, LoRa injects a small secondary set of trainable parameters directly into the model's layers.
Understand.
You freeze the original highly optimized Llama 3 weights completely. You do not touch them.
Oh, wow.
You only train this tiny, highly efficient new adapter network on your highly specialized proprietary data.
So it acts as like a lightweight filter or lens sitting perfectly on top of the immutable base model.
Exactly. The foundational reasoning, that deep logical capability proven by the human evil benchmarks, remains completely intact.
It's untouched.
Untouched. The adapter simply steers that vast, generalized intelligence toward a hyperspecific domain.
It's like generating financial compliance code, routing internal legal documents, or assisting in medical diagnostics.
Precisely.
Well, that completely flips the chaos argument on its head.
It really does. The open source nature isn't a liability at all.
It's a feature. It actually accelerates enterprise adoption because it allows for infinite, highly secure customization without ever risking the degradation of the core intelligence.
Exactly. You get the baseline genius of Meta's massive compute spend tailored entirely to your private data.
And it invites this massive collaborative approach to development.
Yeah, a crowdsourced advancement of the technology. When millions of researchers and engineers have full access to the underlying weights, they build specialized adapters and security tools vastly faster than a single proprietary company could manage.
You get the collective security and peer review of a globally scrutinized system, combined with the ultimate flexibility of localized private deployment.
It's a fascinating strategic dynamic.
It is. The proprietary giants built incredibly powerful systems by siloing the smartest engineers in the world in one highly funded room.
Right. And Meta's response to that is to hand a comparable, highly efficient system to literally every engineer on the planet, betting that the collective output outpaces the silo.
And historically, betting on the collective innovation of the open source community has been a highly successful strategy in software development.
So what is the ultimate takeaway for you listening to this today?
That's the big question.
Whether you are a developer looking to build a new tool without licensing restrictions, or just someone trying to understand the rapid pace of tech,
Yeah.
the barrier to entry for world-class AI has officially plummeted today.
The floor of what we consider the baseline standard has been raised dramatically.
Yeah.
The foundational tools required to build complex, reasoning-heavy applications are no longer locked behind a corporate paywall. They are distributed, they are hyper-efficient, and they are available to anyone with an internet connection and an idea.
Which brings us to the most pressing, forward-looking strategic question of this entire deep dive.
Let's hear it. If Meta has successfully commoditized the foundational layer of AI, setting a new, incredibly high benchmark for what developers expect to get for free, how does the rest of the industry respond?
Right. The business model of acting as a toll booth for intelligence is suddenly under severe existential threat.
Exactly. If top-tier performance, hyper-efficient context windows, and deep coding logic are now just the baseline public standard, what exactly do companies like OpenAI or Google have to invent next just to justify their existence?
Or their monthly subscription fees.
Right. If the public park is offering a championship-level experience for free, the proprietary country club is going to have to build something truly unimaginable just to keep their members from walking out the front door.
It's going to be a fascinating couple of years.
It really is. Something for you to mull over as the dust settles on today's massive release. Thanks for joining us on this deep dive.